body or brakes must be recognised as a load, just like a headlamp. And like any other load, it requires a clean and stable voltage supply and an unrestricted ground path to operate as designed. Before making the decision to replace an often expensive control module, it's critical to first confirm it has everything needed to operate correctly. And the best way to verify the integrity of the supply and ground paths is to test the circuit dynamically using voltage drop. In the past, we've demonstrated how to perform a voltage drop test on a basic electrical circuit using the existing load as the central test point. We can do the same with a control module, except we need to remove the module and perform invasive testing to the connectors in order to access the circuits involved. Control modules often have multiple supply feeds and ground connections. Some may be hot when the key is off, or when the ignition or accessories are turned on. This process can be a time-consuming and complex operation at best. But let me show you an easier way to check these circuits. We still need to identify the supply and ground terminals at the module connector. This information can be found in a reputable service information system. With the power and grounds identified, the next step is to disconnect the wiring harness connectors from the suspect control module. Be sure to follow all OEM procedures when disconnecting any control module. This way we'll avoid accidental damage to the unit. Now we need to determine which of the supply feeds is hot at all times. That is, which ones are always supplied system voltage regardless of the key position. We can also identify these using a digital multimeter and checking each pin in the connector with the key in the off position. Don't use a regular meter probe for this test. Make sure you select the correct diameter and shaped test lead from a kit like this one. The connection that provides a value equal to source voltage is the one we'll start with. With the hot at all times feed now identified, we can install a substitute load for testing purposes. Using a substitute load makes the entire testing process easier. It also helps avoid unnecessary damage to the module connector and harness. We need to select a load that makes the circuit work reasonably hard. This places electrical stress on cables, joins and connectors, which makes measuring voltage drop easier. To determine the approximate current draw of the module under test, and therefore select an appropriate load, take a look at the amperage rating of the fuses in charge of protecting the same module. The substitute load chosen should draw no more than 2/3 of the module's fuse rating. This prevents damage to the circuit when testing. An example of a substitute load is a simple low beam globe. At 55 watts, this will draw less than 5 amps, which is safe for most vehicle systems. Our next step is to connect one side of the load to the module's voltage supply pin. This is the same one we identified earlier. Attach the other side of the load to one of the pre-identified ground pins and complete the bulb connection. The globe should operate and be bright. With the load operating, it's time to perform a voltage drop check on the circuit with the meter set on millivolts. Let's place the negative meter lead on the positive battery terminal, as close to the post as possible. We can then place the positive meter lead on the supply side of the connector at the load. We attach the test leads in this position so that we don't measure any introduced resistance from our load device. If the meter displays OL, then there's a problem in the supply circuit under test. Remember that when OL is seen on the meter, it indicates the voltage drop is outside of an acceptable range. We can isolate the fault the same way we would any other voltage drop test, by moving the meter lead back towards the battery until the source of the unwanted resistance has been identified. If the meter value displayed is less than 100 millivolts, then we've proved that this supply circuit is operating correctly. This circuit can now be identified as our known voltage supply and can be used when checking all ground circuits. Let's move the negative meter lead to the negative battery terminal, again staying as close as possible to the battery post itself. We can then place the positive meter lead on the ground side pin in the module connector. This is the same one that the load is attached to. An OL reading seen here indicates a problem. A meter value of less than 100 millivolts means we can move on to the next identified ground connection. Move the bulb's ground jumper lead to this pin in the module connector and repeat the ground side voltage drop test. Repeat this procedure for each identified ground connection used by the control module. With all the ground path circuits either tested or repaired, we can complete checking the module's supply feeds by moving the bulb positive jumper accordingly. Again, remember that voltage drop checks are a dynamic test, meaning the circuit must be operating during the measurement. If the circuit under test requires the key to be turned to a different position for current to flow, then do it now. When testing the remaining circuits, if the meter displays a perfect 0 volts, then there is no current flowing in that circuit. This means that there is either an open circuit present or the circuit is not switched on. Move the ignition key to each position and verify the integrity of that circuit's related fuse before digging into the harness looking for an open. Voltage drop testing is a dynamic check of a circuit's resistance and is far superior to any static voltage or resistance test. Following these simple steps is critical to prove or disprove that the suspect control module has what it needs to function. Then, and only then, can you replace the suspect module with confidence.